Welcome to Unit 3, and our first chapter of Unit 3 is on mass wasting, which is a short chapter, and we're going to start it with my very favorite mass wasting video. This comes out of Japan. Short but great. I always have to back up and watch that part again. So there's a new landslide scar. There's the road that you just saw, and there's the river below. What you can see is when they back up and kind of pan out. So again, that's where the barricades were. You'll see there was another landslide scar over here from the past, and there it is. Fun. So mass wasting, as you learned in your discussion forum, is just when material moves downhill as a result of gravity. And as you likely discussed, there are many reasons and factors that can increase the potential for mass wasting events. What we're going to talk about in here is the type of mass wasting events that occur. Some of them are fast and some of them are slow. When we finish talking about the different varieties of mass wasting events, we'll have a short activity where you kind of pull all of this information together to make sure it's all in one spot. So the first type of mass wasting event we're going to talk about is likely something that you've seen before if you've spent any amount of time outside or even just looking out the window of your car. And the first type of mass waste movement we're going to talk about is called creep. It's basically when soil creeps downslope. Soil and what's called regolith. Regolith just means weathered rock. And as there are time periods when it gets warm during the day, soil and regolith tends to expand, and then at night it tends to contract. And this cycle of heating and cooling means that the soil is mobile. Not incredibly mobile, but mobile enough that as it expands and contracts, it is also then responding to gravity, and so it'll drift down slope. So you can see features that are related to creep when you see like tilted gravestones or a fence that's tilted, broken retaining walls as they start to lean down slope, tension cracks in pavement, curved tree trunks, as when those trees were young, they curved so that they were sticking vertically out of the ground so that they could get as much of the sun's rays for photosynthesis. All of these are characteristics of creep. It is an incredibly slow process. This might take decades to occur, but it's really, really pervasive. Okay, and here's just some pictures of creep. This is just a walkway, and these are tension cracks, and that's because the soil beneath this walkway is actually drifting towards the left. Here's a very distinctly curved tree trunk as the soil moves down slope with the tree and its root system sort of within it. This is a tilted barbed wire fence that was initially put in vertically, but over time the soil kind of drifted down slope. All right, this is a different sort of mass wasting event. It's also incredibly slow. When you look at this picture, after you kind of take in the beauty, I guess, your eyes probably notice these like lobe-shaped features. This is called soliflexion. And there's a really ridiculous but enjoyable video if you watch the soliflexion video here. And basically, soliflexion occurs in two places. Soliflexion translates to the soil is flowing. It's the gradual movement of soil over an impermeable rock layer or over permafrost. So permafrost is permanently frozen soil. What will happen is that there will be sort of infiltration of rain, and it hits a layer that the rain can't penetrate, and that might be an impermeable rock layer, a rock layer where the groundwater can't penetrate deeper than that. It kind of saturates the surface of the soil, and then the soil kind of slumps downhill because it's just saturated with water. Similarly, this can happen over permafrost, permanently frozen soil. So above the layer of permafrost, and actually what I really like about this video, in addition to the fact that I have an appreciation for the ridiculous, which this video definitely is they actually show you what permafrost looks like. If you were to drill a tunnel down through some of the Alaskan wilderness, you see this layer of permafrost. And so what's cool is that all of the soil above the layer of permafrost or permanently frozen soil can get saturated, and that's what creates these lobes. This is a picture taken outside of Anchorage, Alaska, where soliflexion is an issue. And then the video also talks about ice wedges in Alaska that collapse and also will then disrupt any structures that are built on the surface. All right, this is a picture of Point Furman outside of Los Angeles, California. And what you see outlined here in red is what's called the Point Furman Slump. And you can see there was a walkway that was here that was then had to be closed and rerouted. One of the things you probably should take note of the fact is that there's a lot of silt and clay in the rock that is exposed here. And this is what's called a slump. A slump is the downslope movement of rock and soil, but as a coherent unit. And the reason is that clay and silt tends to be sort of electrically charged. So the positive and negatively charged clay particles, they stick together. Clay is really sticky. So if you think about like pottery, right, that's made of clay, and under the right conditions, that can be really sticky before you put it in the kiln and it becomes sort of a solid forever. So there's a curved surface, both on the surface of a slump and actually you'll see in sort of the interior of a slump, and that marks where the failure of the slope is located. So right there. So in addition to having that curved surface at the top of the slump, there's actually a curved point of rupture within the slump as well. And what happens is that, again, because the slump is characterized by this material that is very cohesive, it's kind of sticky, it tends to break into chunks, and those are called slump blocks. So here is one slump block, here is another slump block, and this is just some surface failure. These sharp areas where the slump block kind of digs into the surface below, those are called scarps. And so slumps are characterized by scarps and blocks. So the scarp is the part of the slump where you can actually see the soil where the actual sliding has occurred. So there's been sliding here where this block used to be up here, sort of parallel to this block, and now it's moved down here and it's slid down here as well. Here's some pictures of some slumps. So again, here is one slump block, there's a scarp, there's a next block, and there's a scarp and another block below it. So that's fun. Ooh, time for some videos. So debris flows are when you have a large volume of water and the water is full of material. So debris flow is kind of my old professor would call it a garbage can term, because there can be different varieties of debris flows depending on what is flowing downhill. Sometimes you can have a lot of soil that's flowing downhill or regolith. Sometimes you have debris. Sometimes you have volcanic material. So I'm going to show you a short video from the Pariah River in Utah. One of the cool things, but also things you have to be aware of in desert environments is that, like near the Pariah River, is that when it rains, which is rare in the desert, right? When it rains, the water doesn't really percolate into the soil or infiltrate into the soil. The soil typically has like a crust on the surface that's often called calicate. And so the water will just flow over the surface and will rush into riverbeds that are dry most of the time, except when it rains, and then there's water in them for a few hours. What that water will do is erode any of the material sort of on the base or on the sides of the river channel, which is what you're going to see here. This video comes to you from Dave Rankin, who is an interesting individual who lives in Utah. Basically, he goes around and chases storms in Utah so that you can get some of this really cool footage. This is called a debris flow. And it's called a debris flow because the stuff that is ripped off of the stream channels here is mostly just debris like plant life. And so that's what's mostly being carried down here. And you can see that it comes in, and it did come in. I'm going to just back it up for just a second and then fast forward. It comes in like one big wave front. So it rained back here, and then all of this material gets flushed out and carried downstream. And so you have, during these periods, a whole bunch of debris that comes in from the sides, and it also moves through in like the course of a couple hours. And then once all of this rain has cleared up and all this water is flushed out of the system, this will go back and be a dry riverbed again. So you can see this debris flow continues for some time. And then eventually, we have some period of debris flow going on here. But eventually, we'll return to basically just water, because most of the debris has been ripped off of the sides of the banks. So like that's what you see here, a return to mostly water. What's true of all debris flows, regardless of what exactly is moving downslope, is the fact that there is a tremendous volume of water that's involved in this. So in this case, in Utah, there was 3 inches of rain that fell in about 2 hours in 2012. Debris flows are particularly susceptible in desert climates, again, where there's low permeability of soil. So permeability is the ability of water to penetrate down into the soil below. Here's an example of a mud flow. I believe that this one is in Switzerland. Give it just a second. Let's drag this over. Oh, no, this is another one in a desert road. Maybe. So this is called a mud flow. It's a variety of debris flow. It basically just involves a large amount of mud. You don't see nearly the same amount of plant life as you saw before. This is also in the United States. And again, you notice that this is in a desert-like climate. You can see the sagebrush and the cholla. Other materials besides mud and plant life that can move down through stream valleys, and that an example of that comes from our chapter on volcanoes, and that is a lahar. So a lahar flow is a variety of debris flow that involves water with a high amount of volcanic debris, typically volcanic ash, but not always. This is the eruption of Mount Merapi in Indonesia in November of 2010. You notice that there's a lot of electrical storm with this particular eruption. That's pretty common. So what happens is when there are volcanic eruptions, there's lots of charged particles that are shot into the atmosphere. And so you get a lot of lightning and thunder. And so that will create a lot of precipitation. Water droplets will actually use ash particles almost as like a nucleus. So the ash particles will be shooting around in the atmosphere, and water droplets will form around them, and then you have a lot of rain, usually immediately following a volcanic eruption like this, where you can see this is under a lot of pressure. The pyroclastic flow is right up vertical. And it is a old composite volcano. Mount Merapi is like amazing. So in this month, in November of 2010, there was a huge earthquake that preceded this volcanic eruption, and then there was a tsunami warning and a lahar flow. So a lahar flow is, again, one of these mud flows that is full of volcanic debris, or debris flow full of volcanic ash rushed down through the town. Some of this on the rooftops you can see is volcanic ash that fell, but you can see that this lahar flow went right through this town in Indonesia. Indonesia, fabulous place to die spectacularly. They have earthquakes and volcanoes and tsunamis, and if you wanna leave a good story behind, Indonesia might be your place. Our next variety of mass wasting events is called a rock slide. And I'm going to give you a case study here about the Grovant River. I usually, in a face-to-face class, I'll have my students attempt to pronounce this. This is French, and they inevitably call it the Gros Ventre rock slide, but this is actually a French word. This is in Wyoming. This is right outside of Grand Teton National Park. So a rock slide is when rocks slide together. So again, there's that idea that they're moving down as a unit. And it's the sudden downslope movement of rock. This is the Grovant rock slide. This is Sheep Mountain. And The Gravant rock slide, there's a couple sort of contributing factors here, right? So you have a relatively steep slope. You have water down below. Water is like the number one agent of erosion on the earth. You also have tilted bedrock layers here. And you have an impermeable clay layer. So what happened in 1925 is that there was a period of a lot of snow melt off in Montana and Wyoming. Snow pretty much sticks around until June. So you had a really high sort of melt off of snow, and it saturated all of the pore spaces in the sandstone here. There are also small earthquakes in the region, and the bedrock layers are tilted. So what happened on June 23rd, 1925, in less than 3 minutes, is about 50 million cubic yards of debris cascaded down Sheep Mountain near the small town of Kelly, Wyoming, which today even is incredibly small. What happened was that debris blocked the Gravant River, and it created a lake behind it, which you can still see the remnants of today, called Lower Slide Lake, which is kind of fun. So in fact, here is, I've taken students there a bunch of times. Here we're standing on that very same rock slide, and you can see this is the 1925 landscape scar, or rock slide scar from the Gravant rock slide. In 1927, 2 years later, there was another period of high precipitation, and the water within the lake got incredibly close to the top of the dam. And the people of Kelly lived downhill of all of this. So there's this great story of a cowboy, because there are still cowboys in Wyoming, which is fascinating. And the cowboy had left his lawn chair like right on the banks of Lower Slide River, or Lower Slide Lake. And then he was down near Kelly and saw his lawn chair floating down the river. And he knew that meant that the lake was starting to overtop the dam. And if the lake overtopped the dam, it was going to just bust through the dam and create a wall of water that was going to move down the slope. So the cowboy got on his horse, raced to Kelly, and just in time, because the top 60 feet of the dam gave way to the water and came rushing down towards Kelly, nearly obliterated the town. But thanks to the cowboy, only 6 people were killed. It's a great story. Honestly, there's not that many more than 6 people living there right now. It's very small, but it's so cute and beautiful. So, Gravant rock slide. You don't have to know the details of that. It was just really to kind of give you a little context. Here's a rock fall. This is a very small rock fall outside of Estes Park, Colorado, which is right near Rocky Mountain National Park. And the difference between a rock fall and a rock slide is the rock fall is really random. There's no organization. The rocks just end up in a pile, as opposed to a rock slide where all the rocks sort of end up in one small area. And again, it's just more random with a rock fall. This is probably something you're familiar with. This is an avalanche. Avalanches also happen when you have the great buildup of snow. And eventually they can reach a steepness where becomes unstable, and so you have the chaotic jumble of snow downhill. One of the coolest jobs that one of my students ever told me about was a guy who was working in Montana in the Rocky Mountains, and he was working on avalanche prediction. And so they would go out and figure out the steepness of the mountain, and if it reached sort of a critical steepness where they were worried about avalanches, they would actually shoot cannonballs into the mountain to cause the avalanche at a time when they knew that no people were there to, protect human life. But what a crazy job to decide when you were going to shoot cannonballs into snow. Is pretty great. I wanted you to see this picture. This is what it looks like in the spring when all that snow melts from the avalanche, and you can see that it just completely annihilates all of the trees and area down what's called the avalanche chute. So that is the end. I want you to take some time and do a little review activity about your 6 mass wasting events. And that's it for chapter 10.